For these examples, we are going to be doing primality testing. And primality testing is a way of seeing if a particular number is prime or not, especially if that number is particularly large. We're also going to be using a calculator. This is a scientific calculator. This particular one is a TI-30. That's a particular brand that I like to use, especially this model. This model seems to satisfy our needs for this section. But you can use any scientific calculator. A scientific calculator should have a square root key. That's this one right here. It should also have a square key. This is a caret key. A caret key allows us to raise a base to a particular power. Should also have a pi key and this logarithm key right here. So for primality testing, this one says determine if the integer 967 is prime. If 967 is prime, then it only has two factors, and that's 1 and itself. However, if 967 is not prime, that must mean it's composite. And we've seen that a composite number can be broken down or factored into a series of prime numbers. So if we have two values, a times b, one of these numbers has to be prime. So there's a lot of prime numbers that we would check, but there's a way to limit how many we would need to check for this. And what we would do is we would take the square root of 967. So on our calculator, here is my square root key right here. And since it's in green above the key, we have to hit this second key here first. So I'm going to go second. And there's my square root. And type in 967. Now for my particular calculator, when I hit enter, it gives me the exact value. It spits out square root of 967 again. Well, I want the decimal approximation of this. So I have these double arrow keys here. Now yours may be different, but if I click on those double arrows, it'll give me a decimal approximation. If you're not using a TI-30 type of scientific calculator, you may not have these double arrows. You may have a mode key or something that you would have to set, but that's something you would have to investigate. But we can see that the square root of 967 is approximately 31.1. So what that means is that all we have to do is check all the primes less than 31. So the primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. So we only have to check the primes between 2 and less than 31, and these are them. Now we can see that 967 is not even, so we don't have to check 2. 2 will not divide into 967, therefore 2 won't be a factor of 967. It doesn't end in a 5 or a 0, so we won't check 5. 5 will not divide into it, so therefore 5 will not be a factor. Also, we've seen that if we add the digits up, 9 plus 6 plus 7, that comes out to be 22. 3 does not go into 22, therefore 3 will not go into 967, so we don't have to check for 3. So that eliminates some of them, but then this is where our calculator will come in. I'm just going to go 967, and I'm going to divide it by 7. If 7 goes into 967 evenly, then 7 is a factor of 967. So we'll divide it by 7, and it's not an integer, it's a decimal. So 7 doesn't work. So now I'll try 11. That also doesn't work, that's a decimal. And I'm just going to go down the line here of all the primes. 967 divided by 13. 967 divided by 17. 967 divided by 19. divided by 23, and I'm looking for an integer output. So none of these primes divide into 967. So therefore, there are no other factors for 967 other than 1 and itself. So since there are no other factors, then we could say that 967 is a prime number. We're going to do the same for example 3 here. We're going to determine if 259 is prime. So we're going to do the same thing. We'll take the square root of 259. I'll do my second square root, 259. Hit enter, and then I'm going to hit my double arrow keys here. So the square root of 259 is approximately 16.1. So all I have to do is check the primes between 2 and 16. That's 2, 3, 5, 7, 11, and 13. Again, we don't have to check 2. 259 is not even, so 2 will not factor into it. Doesn't end in a 0 or 5, so 5 will not factor into it. 2 plus 5 plus 9 is 16. 3 does not go into 16, so 3 will not divide into 259. So all I have to check is for 7, 11, and 13. So I'll take 259, divide that by 7, and look at that, 37. So we can say that 7 times 37 is equal to 259. So since there are factors other than 1 and itself, then we could say that 259 is not prime.